Okay, thank you everyone for coming. Please grab your seats. This is the next panel. We've had some great sessions earlier on and hope you all have enjoyed them. This panel is going to focus on the transportation sector. In general, we can refer to it as the mobility sector. And of course, we are going to address the impacts of climate and how can transportation sector be more resilient with all these changes that are happening. Thank you all again for coming. So the way we'll run this panel is initially I'll let my distinguished participants introduce themselves, their name, their affiliation, and what sector of this topic do they relate to in their work life. And then we'll go around, ask a few questions. So I'll lead them through a set of topics. And hopefully at the end, we have a few minutes for some of you to ask the questions also. So let's get started. I'll start with Carlos Cruz-Casas. Maybe introduce yourself. Please keep it to 2 minutes.
Perfect. Good afternoon. Can you guys hear me? Excellent. Well, my name is Carlos Cruz-Casas. I'm the Chief Innovation Officer for the Department of Transportation and Public Works in Miami-Dade County. I know that sounds like a mouthful and perhaps doesn't do justice what we do. I'll tell you, we like to consider ourselves as a mobility management agency. We're fully responsible of traffic control devices, traffic engineering, highway engineering, transit planning, transit operations, paratransit, regulatory arm for for-hire vehicles, so basically anything that's mobility in Miami-Dade County. My role is simple, is to bring mobility innovation, not necessarily about technology, how we address the problems that we have, and to make sure that we plan for all that collectively into one system.
Good morning, everyone. Can you guys hear me okay? Good afternoon. I'm Guillermo Aleman. I'm the Manager of Technology and Innovation for Florida Power and Light. And my role is kind of unique in the company. I get to play with all the new stuff and see how it integrates into our system and how we could use it to improve power quality for our customers. So I look at everything from equipment itself, right, and how we can deploy it and what benefits it brings and how we consume the data from smart equipment, how we're going to deploy that equipment if we do decide to use it, and then AI and what we call situational intelligence around that data. So how do we use that to make it easier for our employees to do their job and improve reliability as a whole.
Okay, Raimundo.
Hello, good afternoon. Thank you. My name is Raimundo Rodulfo. I am the Chief Innovation Officer and Director of Innovation and Technology with City of Coral Gables, the City Beautiful, home of the University of Miami. So we provide technology, innovation, and best practices to continuously improve quality of life for our residents, for our citizens in all the different areas and verticals, from public safety to mobility to transportation, quality of life, and citizen services. And we develop the infrastructure of our smart city that goes from fiber optics and broadband to IoT sensors throughout the city to connected clouds and artificial intelligence platforms to digital twins and smart city hubs to provide digital value to our residents. Thank you.
Mingzhe.
Good afternoon, everyone. So I'm Mingzhe Chen, an assistant professor at the Electrical and Computer Engineering Department of the University of Miami. My research focuses on the design of novel machine learning algorithms such as federated learning and reinforced learning, and their applications for unmanned area vehicles, transportation networks, V2V networks, and communication systems. So in particular, in our group, we focus on the design of multi-agent reinforced learning for UAV identification, UAV localization, and their trajectory design for human detection. Yeah,
Great, thank you everyone, and I'll introduce myself.
Well,
Should have. Oh, sorry.
Yeah.
Brian.
So I'm Brian Freed. I'm the Chief Operating Officer for Eagle Aerospace. I walk a unique line. I'm responsible for both the P&L and the products of a technology company that is a subsidiary to one of the largest airfield equipment distributors in the world. So I have the unique honor of saying that we sell the world's biggest snowblower and machine learning software. So we service airports, and as we look at the challenges of mobility and resilience, we're focused on how can we use technology to enhance the safety, the productivity, and sustainability of airfields.
Thank you, and shouldn't have missed you. My name is Pratim Biswas. I'm the Dean of the College of Engineering. I myself focus on small particles in the field of aerosol science and technology, the backbone of nanotechnology, and do many different things. So thank you again for coming. As I indicated, I'm going to lead the panel through a set of questions, so we cover the transportation sector maybe in an organized manner with respect to resiliency and what might be coming in the future. So let me start off with Carlos. If you want to give us a description of some of the existing modalities of transportation, what are some of the technologies, some of the challenges, and what is coming in the future.
So excellent. Well, I'll be remiss if I don't mention this rain, right? And a couple of years ago, I went to a trip in Copenhagen, and I asked the person, how do you deal with biking and moving around in such a rain? And the person told me there's no thing as bad weather. It's the thing about bad clothing and how you dress in order to participate in that and be able to get your raincoat and move around. But that on that side, what we see is that our lives have become depending on a lot of diversity and abundance of options, from Amazon store to shows in Netflix or picking ice cream to be delivered to your house in Uber Eats. So mobility should not be any difference. So what we're looking into is a mobility ecosystem that brings all options available, whether it's on transit, on bus or rail, where there is on-demand transit component, which is actually getting some good momentum these days, share rides, bicycle, e-bikes, scooters, one cycle, all these things can play a role. It needs to be consistent in a way that can be brought together. One of the things that we've seen is that technology can play a big role, right? In particular to improve the efficiency and the safety of the vehicles on the road. You probably heard about self-driving vehicles or autonomous vehicles running around. We have Ford and Argo where testing their technology here in Miami-Dade County. And it's a component that we need to start understanding how that can be applied to mobility. We currently have, actually sunsetting this Sunday, a demonstration with an autonomous shuttle at the zoo, right? Looking at autonomous technology, self-driving vehicles that can move people efficiently and safely. And what I'm expecting is for that to be applied for systems that can feed into a good transit network. So first and last mile connectivity, or even that's only mile that's very short, on demand, similar to what you see with the Go Connect program, with the Freevee or the circuit programs, fitting into heavy rail system and a full bus network redesign that's coming in later this year. And from there we'll go to the skies, but these guys have us covered there.
Great, thank you. So clearly, I mean, in a city network, in an urban system, in a smart environment, we have to be dealing with the entire transportation network. So thank you for pointing that out. And of course, when it comes to the transportation network, we got to deal with the grid, with companies such as FPL. So how does FPL support the resiliency in this transportation network? And you might then also allude to the future transportation needs and just give us some examples of what your company is doing about it.
Thank you. So electricity has always been important for transportation. Am I not on? Can you guys hear me okay? Yeah, I'm good. So electricity has always been important for the transportation networks. And today you guys see that when it's missing, like when we have a storm and the gas stations aren't working, it's a challenge. When you really think about the future and the electrification and electric buses and electric vehicles, it becomes even more critical, right? So the resiliency of the network is important. FPL over the last couple of decades has been preparing for that through the hardening efforts. So if you really look at what we've done over the last years, and you guys may have seen it right here in Miami where we're going in and replacing poles and improving areas or putting it underground. It's really about being able to maintain that. And if you guys heard Tony in the last panel talking about Babcock Ranch, that's a perfect example of what happens when the network has been upgraded. They didn't lose any panels. All of the solar site was built to Category 5 storm, and all of their feeders that fed that neighborhood was built to Category 5 standards. So they didn't lose any of the feeders or any of the panels. They continue to go even though they took a direct hit from a really large storm. And we're doing that across the state with the transportation sector in mind. So that first phase, right, how we're preparing for it is really about hardening the system and improving the system's ability to withstand future weather due to climate change. But in addition to that, phase two really is about prevention. So how are we preventing those outages? And that's what my team works on, is using the information coming from the smart grid and AI to do prediction and to get smarter around where we spend our resources so that we could get to the places with real problems faster. So last year, just to give you guys some numbers, FPL proactively identified locations that were gonna have an outage and went out and replaced it or repaired those areas in 13,000 cases last year. It's a large number. But we also prevented 22,000 trucks from rolling to locations where they didn't have to be. These are places where customers are calling and saying, I have a problem, but really it's internal to their home. They have a blown breaker or whatnot. Before we would send an investigator there, today we can proactively identify that that's the case and let the customer know and be able to send that resource to the right place. So that's the prevention, right? And then the proactive piece of it is really taking that and doing the situational intelligence, right? Giving our employees the ability to grab all of that data from the field and see it in ways that allows them to do their job faster. So where we used to spend an hour having a planner trying to investigate how they're gonna do something, today they can do it in 5 minutes. So all that together allows us to build a network that's stronger, faster, and more able to support the needs of the future. Now, hardware-wise, as part of the hardening efforts, we're putting smart switches out there in the field that allow us to route problems around, or route power around problems. So when you think about, you know, if we weren't able to prevent it, we weren't able to harden around it, now we have a real problem. A tree fell in the line, you know, a squirrel gets across, somebody hits a pole with their car. In the past, that could have been 2,000 customers that are impacted. Today, it's 500, because the switches will automatically reroute the power around that problem and isolate it down to a smaller section.
Great, thank you. So from this like whole holistic regional kind of effort that larger utilities look at, let's come down to our neighborhood here, Coral Gables. Of course, a wonderful location. So how would a city, you know, bring the smartness into its operations with respect to hyper-connectivity, hyper-automation, connected mobility, and even the concept of decarbonization? This is an extremely important aspect. So maybe Raimundo, you can give us some overall description how a city goes about some of these things. Yeah.
Yes, so I would say we started first building that foundation of high-speed communications with a resilient and robust network that can survive hurricanes. For example, I maintain critical services for first responders, for 911, for critical services for the citizens. So we went, for example, when I started in the early 90s as an electrical engineer in the telecommunications industry. So after I worked for more than 10 years in the private sector, I joined the city in 2004. And I was welcomed by a series of hurricanes, I remember. So multiple names that I don't want to remember today. And we lost power because we are Tree City, USA, so we have 40,000 trees in the right of way, and the overhead power lines were affected. We are collaborating with FPNL now on the undergrounding of utilities. So those things are not gonna be a problem in the future. But because of those many trees and falling lines, we had 80% power, for example, down in some of those hurricane events, and we lost communications, and that affects our ability to fulfill our mission, our critical mission of providing public safety services to our citizens. So that priority was, let's build that robust, resilient, high capacity, high speed network that will provide services for normal operations and for smart city services like sensors and other things that we are enjoying today, But at that time, it was about the basic survival and critical services. So we built that layer with fiber optics corridors that we built throughout the city, and a wireless gigabit point-to-point and point-to-multipoint backhaul as a redundancy to the fiber. And we also be connected to Metropolitan Ethernet services, to wireless cellular services, and to satellite services. So when everything fails, we have satellite. And we have deployed satellite services also as a mutual aid recent hurricanes like Hurricane Ian and also Hurricane Maria. So we have that capacity with automated failovers and fault tolerance. That's the key, that's the foundation of that building, that engineering framework for smart cities. Then we build that layer of cyber-physical systems, of IoT sensors, multimodal traffic sensors that count pedestrians and vehicles and bicycles or micromobility, and also environmental sensors that have flood alert, but also water quality sensors in our water canals, and also air quality sensors and CO emission measurements. And smart poles also throughout the city with CCTV and automated license plate reader for police safety sensing, and other capacity also for economic growth, to provide data to the businesses that can leverage that data for the bottom line, and also to provide better services to their customers. And then we aggregated all that data, millions of data points, in distributed cloud with machine learning, artificial intelligence. That is the only way we can make sense of millions of data points weekly to provide actionable insight where to the public. So we democratize the access of data with our public platforms. If you go to coralgables.com/smart city, you will see our smart city hub where we share the data with everybody, with the public, with the residents, with researchers, with traffic engineers, urban planners, businesses, and also access to our digital twin, where there's a lot of apps and more than 2,000 data sets open to the public, including real-time data from sensors. So all of that fosters the innovation, the collaboration and partnerships with the industry and with entrepreneurs, but also we become an experimental city. I just came from ARPA-E, from the Energy Innovation Summit, where we are collaborating with the DOE, for example, interconnecting the traffic signals with connected and automated vehicles in real time using a new technology that we are developing with the Pacific Northwest National Laboratory. So those kind of experiments, they happen because we have built that fabric of hyperconnectivity and automation that allows us to collaborate as well.
Thank you. Yeah, so that gives you a perspective. You know, transportation, you might just think it's bikes, cars, buses, trains. It's way beyond that. You bring the smartness in. We've heard about sensor networks, data systems, and that sort of transitions also connects to things like the Institute for Data Sciences. So let's take that next step, look towards the future. And of course, those who live, most of us live in Miami here, always complain about the traffic jam coming into work at certain times. So how do we address even some of these problems? How do we overcome some of these problems? As was mentioned, these large data sets might enable us to build algorithms and so forth, but let's really take a technology leap and look at what is beginning to happen. And there are groups now addressing this, concepts of autonomous mobility, advanced autonomous mobility, where you literally bring in concepts of electric propulsion, and in a simple way just say that your car can start flying like a drone, overcome traffic jams, hurdles, and so forth. This is quite realistic. Miami is a test bed. There are many startup companies and so forth developing technology. So let's take that leap and see what is going to enable it. You've heard many things which are very relevant even for existing technologies like safety, regulation, data systems. To make all of this happen, one would have to do a very high level of advanced data analytics in real time. Concepts like artificial intelligence, machine learning will come in. So Dr. Chen, next question is for you. You're an expert on AI, ML, algorithms. So how do you see these applied to transportation networks? Of course, they're already being applied, but looking at the futuristic way, and how will AI ML enable development of and deployment of some of these technologies?
Okay, yeah, thank you. So right now, actually, we are studying using supervised learning and reinforced learning for transportation system. So in general, we will use these algorithms for two types of applications in vehicle networks. So first, we try to do the data analysis, such as vehicle data and traffic data, as well as human or driver behavior data. For example, we can analyze the traffic at different roads and to predict whether the road has traffic congestions, and also we can analyze the behaviors and also the mood of the drivers, so as to predict the vehicle accidents. So on the other hand, we can also study. We are trying to use reinforced learning for autonomous vehicle control as well as unmanned area vehicle control. So here actually we consider two types of vehicle. One is on the ground, another one is over the air. Then the different thing is that for the unmanned area vehicles, we consider more on the trajectory design as well as how to use limited energy to carry packages and also try to deliver services. On the ground, we are trying to use reinforced learning for vehicle speed control, vehicle routing problems, as well as vehicle identification. So currently, actually, we are trying to use machine learning for vehicle identification, localization, as well as UAV identification. This is because you can see that different companies may have different UAVs, may have different autonomous vehicles. But the problem is that how could we use machine learning to identify different vehicles and identify the UAVs over the air? So that's two basic applications of machine learning.
Okay, thank you. So it's a very exciting time really to work in this, and a university like ours, we have an initiative going through multiple schools and colleges on autonomous mobility. We call it the Miami Engineering Autonomous Mobility Initiative. If anyone is interested, please join in, and I'll say the same to my panelists too. So, of course, you're not looking at, you might say, oh, we have helicopter technology. I see that flying all over Miami. You know, there are concepts of noise, there are concepts of safety, there's the concept of the actual infrastructure, where do these vehicles take off, land, and so forth. So coming, and we are delighted to have someone from the aerospace industry with us on our panel. So how would efficient, reliable communication of, I'll use the term airfield conditions, etc., be enabled, vehicle locations, flight device location, sensor data, how are all of these sort of combined, and certain goals of ensuring safety and things like that? So could you give us an overall description of the infrastructure?
Certainly. So there's really kind of two challenges that have to be addressed in any environment. So the first is infrastructure resilience, and then the second is operational resilience. So this kind of falls into the infrastructure resilience side. Airfields are a little unique. So from the terminal to the fence, they've been late adopters to technology because safety is kind of paramount. So what you find in that environment is limited connectivity options, and while many industries have really moved into the next era of connectivity, the airfield is widely disconnected. And so what you're seeing is a move away from traditional wire-based solutions to wireless, but as you're putting autonomous solutions on a high-value airspace, you need not only reliable connectivity, but redundant connectivity. So if you have an issue with one network, another. So there is no one single technology that wins all. For high bandwidth, high performance connectivity, we're seeing a combination of 5G and wireless backhaul solutions that can provide different methods for high bandwidth connectivity in a wireless fashion. And then for the smaller sensors, you see a variety of applications from RFID to LoRa to bring in those low bandwidth but continuous monitoring with the goal of collecting all of the data from everything in a way that you can truly enhance situational awareness and operational response. So the challenge is not only to connect, but also to provide that connectivity in a way that today is consumable by the humans making operational decisions with an eye to a future where it's machine-to-machine communication. So it's that transition from visualization and consumption by humans to machine learning where you don't have those same parameters and concerns.
Thank you. Maybe at this time, let me turn over to the audience. If there's some question for any of our panelists, please feel free to ask. Anyone want to ask a quick question? No? Okay, please. So the question is, I presume you addressed air taxis, so what is the timeline to really see maybe a taxi flying, a car flying in the sky? Anyone, any panelist, maybe?
So in terms of the challenge from the aerospace side is the sharing of the skies with the commercial airlines and the emerging drones and personal taxis. And I think one of the big challenges is the ability to rapidly identify not only where aircraft are, but where they're going to be. And so being able to predict when a plane is taking off, where it's going, so that you can make sure that you don't have incursions within the airspace. I think there is great progress on that. Technologies like ADS-B, which provide continuous location data across all aircraft, it's being mandated in drones in the next 12 months, will contribute to that greatly. The second piece is going to really come down to the folks in the data science world to create those predictive models that are not only addressing where the aircraft is today, or at the moment, but where is it going to be in 5 minutes? Because you really need to have predictability to avoid collision situations. And so I think that is the second piece.
I would add to it that everything goes in phases. So today we have the UAS, or unmanned aerial systems that we use, like drones, manned and unmanned systems that we use for different purposes, to have that eagle eye access for rescue recon after a hurricane, to also to deliver supplies now that we can have drone delivery of supplies from an emergency operations standpoint, but it's happening also from a commercial standpoint. We hear about pizza experiments happening in different metropolitan areas. So that's like the next phase. Then getting to electric vehicle takeoff and landing, to the eVTOL type of applications. It's taking time, but we know that Miami has had some test trials of that. We know that Seattle, we know that New York has done it. So it's in phases, so adoption happens in phases, and safety first, like in everything. So the regulatory framework for safety is what really will drive the speed of adoption. So how fast are we going to have it? So in City of Coral Gables, we are building an amazing project. It's a mobility hub project in the center of our central business district that is going to have the aggregation of electric vehicles, even robo-taxis, UAS, activations in the rooftop, electric vehicles and chargers. So all those things are happening in phases. So we see, for example, the mobility hub being like a step forward for us to bring that multimodality and also new technologies in this space.
Right. So yeah, that's a lot of exciting things.
Well, no, I think that's just phenomenal. I just chuckle a little bit because you mentioned pizzas with drones. Last year in the event, we actually delivered chicken wings with the drones, which I think is kind of a funny thing, right? Chicken wings and flying on drones, but That aside, one thing that I wanted to kind of mention, because I think fascinating that we talked about, predictive analytics and behavior and understanding that and the operational components of it, right? And one of the things that we need to start thinking, and it's already happening, is, someone needs to be the maestro de orchestra, right? Someone needs to provide the rules of engagement on the public right of way. Today, is us, right? We put signs on the streets that says no turn here or speed limit, right? One of the things that are happening, I don't know about you, but when I'm driving, I know more the speed limit of the road that I am driving from my in-dash navigator from my car or the Waze application. So all of a sudden, the private sector is actually providing the rules of engagement and provide that information to you. So this is something that is really happening, and we are taking this head on. I wanted to just kind of a quick plug in here. Miami-Dade County joined another 13 cities from across the nation 4 years ago and created something called the Open Mobility Foundation. And this is a city-led organization that is moving forward a concept and actually a specification for communicating to the technologies on the road through a mobility data specification. And this is, I can provide a speed limit through an API. Like, I don't have to teach an autonomous vehicles or eVTOL or something else how to read a sign, actually providing that in the language that they already communicate. I think it's really fascinating to start seeing how cities can basically be participating on that, providing the rules of engagement of the public right away from an API point of view and be future ready. No coincidence, my shirt today, because Miami-Dade County is moving in that direction.
Thank you. Hope it answered your question. Maybe we take another quick question if there's one from the audience. If not, okay, thanks. Maybe what we'll do now, we have, of course, limited time. We could go on, but just to answer you, I hear that a Brickell to airport corridor will be created for testing of some of these technologies and so forth. So a lot happening. In fact, you could also buy one of these vehicles, though it's not it's not received regulatory approval yet. Let me go around back to my panel and give each of you a chance to maybe conclude for the audience, for each of us here, what you think is, what would make our sector a lot more resilient, thinking about the future, maybe even thinking today. In your viewpoint, what do you think would be absolutely essential to ensure our transportation sector is resilient, robust, and also sustainable for the future? Maybe I just start going down the line here. Yeah.
So I would say that the ability to predict instead of reacting. So using AI, machine learning, predictive analytics capabilities for everything from environment and weather and flooding events to behavioral type of science in urban areas, predicting traffic events, evacuation routes and scenarios, using digital twin environments for multi-scale simulation before going to the real exercise. So having that predictability to me is going to make us more resilient.
So I have to agree that right now the biggest thing for the power industry is also consuming all the data that we have and doing more AI, more machine learning, and more prediction. We do a lot of it today, but the gap on how much more we could do is huge. I think the big thing for us also is being able to keep up with where you guys are going on the green side, right? So today, about 25% of the power that FPL produces is green energy, either nuclear or solar. FPL's goal is to get to zero carbon by 2045, which means over the next couple decades, that's a huge investment in infrastructure and a huge change in the way that we generate power for you guys today. And making sure that we could do that and continue the same level of service is a big problem that's not fully solved, right? So for us, that's a big focus over the next couple decades.
So from my perspective, I think the biggest hurdle in the near term is operational integration and technology. So technology is great, and there's some amazing things it can do, but there are embedded processes that have to be adapted to consume that technology. And so effective technology, whether it's machine learning or AI, needs to be delivered in a way that it can augment and enhance current human capability, current human decision making, because the economic challenge of technology independent of that integration is that the buyers are faced with a situation where they're having to buy the solution twice. So they have to pay for it in its current paradigm. Will they pay for the technology and prove that it actually works well enough to replace what they have? And so to me, it's that operational integration with what exists today is the biggest hurdle to the adoption and use of innovative technology.
Fascinating, and I do believe you talk about resiliency. Electrifying everything makes sense, right? But ultimately, we cannot just continue to think that we can drive alone and we can just continue to make those single occupancy vehicle trips electric, because ultimately we'll be clean air, we'll be stuck in traffic. Right, we're not going to go anywhere. So there's a lot more that we need to do. I've been bullied talking about the addition of electric assist to the bicycles and scooters that are coming in order to move people more efficiently. In an area like Miami-Dade County, we're flat. Yes, it's hot, but if you have electric assist and it can move you very efficiently, and if you have safe infrastructure, then you can get places, right? So I see that as a need. But ultimately, how do we adapt technologies, all these algorithms and predictive analytics to see how we can group people together in one car in order to move them to a connection, right? So we're making great progress with the on-demand transit program that we have called Go Connect, and start introducing self-driving vehicle technology to a system like that. Not only can it help us be reducing the cost of operation, be safer on the streets, but ultimately provide better and more number of vehicles out there, while taking the talented staff that we have driving vehicles and put them on buses and rail, which we need them desperately these days.
So everyone believes that AI will be very important in future transportation networks. But currently, actually, we are all, maybe most of us are just using the existing or CS machine learning algorithms for transportation networks. So we are just using machine learning instead of designing or thinking about how to use or how to design some machine learning models that are suitable for future transportation networks. For example, how we could use vehicle mobility, vehicle control, and vehicle speed to improve the machine learning algorithms, how to use these unique features of vehicles for machine learning algorithm design. I think that's also very important for future transportation networks.
Great, thank you. Everyone, let's give our distinguished panelists a big hand. And this has been really fascinating, and hope you enjoyed it. And I'll turn over the floor to Rudy.